Hello everyone, I am Mehdi Shayan from Clemson University and I'm presenting our abstract titled Are Metrics that Quantify Suturing Skills Different for Performance by Pronation versus Supination? The authors have no disclosures. We have developed and instrumented a simulator to comprehensively assess basic surgical suturing skills. Specifically, our simulator is designed to measure performance on the FVS radial suturing task. The FVS exam is akin to the FLS and will be required to demonstrate proficiency in vascular surgery in the US. The radial suturing pattern necessitates subjects to throw both backhanded and forehanded sutures, giving us the ability to compare their suturing performance during supination versus pronation. Surgeons must decide whether to use supination or pronation depending on the site requiring suturing. But not all surgeons have the same skill level in their backhanded and forehanded suturing. The focus of this study is to examine if objective metrics can shed light on differences in suturing performance with supination versus pronation. Here, the subject is performing a backhanded suture at the surface condition. You can see the IMU on her hand and two EM motion trackers attached to each arm of the needle holder. While in this deep suturing scenario, you can see the subject throwing a four-handed suture. The plastic barrier simulates suturing in a cavity. Now I want to quickly go over the sensors we incorporated in our suturing platform. We have a camera inside the platform viewing underneath the membrane to track needle movements, and another camera is mounted at the very end of the table, giving an overhead view of the simulator and subject's behavior. In order to track how the subjects operate the surgical tool, we sensorize the needle holder with two EM motion trackers. Moreover, a multi-axis force sensor placed at the very bottom of the platform gives us 6 components for forces applied to the membrane. These are the force components we are looking at for this study. Finally, an IMU was placed on the subject's dominant hand, which is the key sensor in detecting their supination and pronation movements by outputting the rotational components of their wrist movements. For this study, each subject completed 12 sutures per trial in 4 conditions. Here's an example of the short thread superficial suturing condition. And this is the long thread deep suturing condition. All subjects were given the same standard equipment, including an 8-inch Mayo Hagar holder and 3 sutures. Our dataset consisted of 174 total sutures from 4 subjects, 2 attending vascular surgeons considered experts, and 2 non-clinicians with no suturing experience considered novices. 18 sutures containing critical tool manipulation errors and corrupted sensor output were excluded from this study. The following skill metrics were computed for all the sutures. The time, computer vision, and force metrics have been used before for differentiating between suturing skills in the past. Our previously published computer vision metrics are a way to assess suturing performance by tracking needle movement. Tool motion smoothness, however, is a new metric added to the platform, measuring the motion smoothness of the needle holder. All sutures were then classified as backhand or forehand using the initial portion of each suture cycle from the IMU rotational profile. The first 2 columns of the table show how the expert supination and pronation suturing skills are compared to the novices. And the 2 rightmost columns show pronation versus supination skills for each group. The results showed that expert supination and pronation behavior differed from novices. As expected, our results indicated that regardless of forehand or backhand, experts were generally better than novices when their suturing performance was assessed using objective metrics. In addition, results also showed differences between the expert and novice groups. For the expert group, we saw significant differences in forehanded and backhanded performance for 6 metrics, whereas with novices, only 1 metric showed a significant difference. Finally, a significant insight from our intergroup analysis is a noticeable difference in skill for the expert group between forehanded and backhanded suturing. In contrast, a significant difference was not observed in the novice group. The takeaway from our pilot study is that suturing with forehand versus backhand may result in important quality differences in sutures. As this research showed potential for further analysis from a larger set of data, we continue to collect data and work towards creating an extensive dataset. We will soon publish new findings backed by extensive dataset of subjects with different skill levels. We believe our simulator holds the promise to enable automated skills assessment for next generation suturing skill training. The authors would like to thank the National Institutes of Health for seeing value in our research and financially supporting this study.